Okay, so question 18 was a really tricky question. We're told that there are two values, two quantities that are related. One's called y and one's called x. It appears to be y which is in control because y is affecting x. X is proportional to the square root of y. So I'm going to do a little table like this. I've got my y there and I've got my x here. But x isn't related to y, it's related to the square root of y. So what that means is there's some multiplier linking those two, and if I wanted to work out the multiplier, I'd always do after divided by before, which in this case would give me x divided by the square root of y. We don't need to do that for this question. So I'm just going to imagine that y is a particular value, okay? And I hope you can see why I'm going to choose this value. I'm going to pretend that y is 100. And the square root of y is therefore equal to 10. So x is equal to some multiplier times 10. I'm not going to bother working out the multiplier, I don't need it. Now if y is increased by 44%, what will it become? What do you get if you add 44% onto 100? I hope you can see that's 144. And that's why I chose 100 in the first case, because it's easy to increase 100 by 44%. It would have been silly to have chosen a different number. Okay, so what's the square root of 144? That's 12. That means that x is going to be equal to some multiplier times 12, the same multiplier as it was when we had 10. And so that means x is going to increase by the same amount as the square root of y. So what's the square root of y increase by? Well, if I do after divided by before, I get 1.2, and I know that 1.2 as a percentage is 120%, which means we've had a 20% increase, which was the answer to the question. So question 21 was a vector question. It wasn't an easy question, I have to say. F to D is A, but we're told that P is halfway along that road. So hopefully you were able to see, lots of you did, that that's a half of A, and that's a half of A as well. And F to E is B. There we go. So these are the only roads I know about. I'm going to highlight them because they're the only roads I know. Okay, so I want to get from P to Q. I want to get from P to Q because I've got to show that that journey is equal to F to E. I know what F to E is, that's just B, so I'll write that down here. F to E is B. Unfortunately, that didn't get you a mark, just writing that, but there we go. Now, how can I get from P to Q on roads that I know? And this was the tricky bit. And a few of you got really close to it. And the trouble is, I don't know anything about the branch down here, do I? I don't know about that journey there. So I'm going to start by saying, right, how can I get from D to E on roads that I know? And hopefully you can see that that's all the way down A, backwards down A, and forwards along B. Now I don't actually need D to E, but it's going to be helpful for me to work out D to Q, and that's half of that journey because we're told that Q is halfway along D to E. So half of that journey will be minus a half of A plus a half of B. So I can now colour in that line because I've got that journey as well. That's that journey there. Okay, now remember what I'm trying to do. I'm trying to work out P to Q. Can I now work out P to Q? Well, hopefully you can see I can. P to Q, I go from P to D, which is a half of A, and then I go from D to Q, and I've just defined D to Q here, so I'm just going to write that there. So that's minus a half of A plus a half of B. Now there's a bit of vector algebra I can do here. If I've got a half of A and I take away half of A, no A's to be seen. So P to Q is just a half of B. Now a lot of you actually wrote that down. You said, well, that has got to be half of that, and it is true, but that's sort of using geometry, not vectors. What we've now shown is that P to Q is a half of B and F to E is B. And do you remember two vectors are parallel if you can show that one is a multiple of the other? Well, yeah. F to E is twice as long as P to Q. It's a multiple of P to Q. So P to Q is parallel to F to E because it is a multiple of. Okay, so here's 23. It's the last question, and well done to those of you who really had a go at this one. All right. We are told about some cards. We don't know how many cards there are, but we know that they're a mixture of black and white, circles and triangles. There are some black circles and some white circles and some black triangles and some white triangles. We're told about the mixture of black and white. It's 3 to 5. So hopefully you were able to see from that that meant that 3/8 of the shapes were black and 5/8 were white. Excuse me. We're also told about the mixture of circles and triangles. So hopefully you can see that meant that 2/9 of them are circles and 7/9 are triangles. But I don't know how many cards there are. So at this point I'm going to do what I did on the earlier question. I'm just going to come up with a number of cards. But I'm not going to use 100 like I did in that previous question. I don't know if you can see why I'm not going to say there are 100 cards. Well, it's because I've got to work out 3/8 and 5/8, and if I use 100, that's not going to be a whole number of cards. And I've also got to work out 2/9 and 7/9, and if I use 100, that's not going to give me a whole number of cards. So what number of cards could I use so that I could work out 3/8, 5/8, 2/9 and 7/9 and there not be any problem? And a few of you came up with the answer. It's a common denominator problem. Because if I say there are 72 cards, that's the first number that I can divide by 8 and 9. Now, I don't know whether there are 72 cards, but I want to know about the fraction of the cards. So it actually doesn't matter. If I pretend there are 72 cards, then 1/8 of 72 is 9. So 3/8, that means there are 27 black cards. And 1/8 is 9, so 5/8 would be 45. So there are 45 white cards. Circles, 2/9. Well, 1/9 of 72 is 8, so 2/9 would be 16. And 7/9, therefore, would be 56. I want to know the total number of cards with a black shape. Well, in my thing, that's 27. As a fraction of the total number of cards with a triangle, 56. Quick check, can I cancel it down? No, I can't. That's my answer. Now, whatever number of cards I chose, I would have ended up with the same fraction. Because I chose the first number in the 8 and the 9 times table, I didn't have to cancel my fraction down. Well done to those of you who had a go at that one.